Okay, so we're up to the part where we sketch this graph. Okay, so I'm going to use the form that I used before. And first of all, the thing that I need to draw is what the asymptotes are. So we have an asymptote at x equals 4 and at y is equal to 1. Okay, so if you look at the form of this graph, it looks something like, disregarding this 1, it looks something similar to 1 on x, right? Except it's double and it's kind of offset over here. All this is going to do is add 1 to this, so it's just going to shift the graph up by 1, which is done by the asymptote. So if I was to draw this graph out, it will look something like this. So you need to be careful what the values are when x is 0. So when x is 0, this is going to be 1 minus a half, so a half. And when y is equal to 0, okay, y equals 0 is a bit harder, so I'm just going to write it out. So 1 plus 2 on x minus 4 is equal to 0. And this would mean 2 on x minus 4 is equal to minus 1. Okay, x minus 4 is equal to minus 2. Okay, so all I did was move that up there and then multiply both sides by minus 1. And therefore x is equal to 2. So that point over there is 2. Let's join the dots up. There we go. Okay, hence otherwise find the values of which x, so yada yada, when, so basically when is y less than or equal to 3. Okay, so you need to find, so for part 2 of this, I need to find when 1 plus 2 on x minus 4 is equal to 3. Okay, so 2 on x minus 4 is equal to 2. I can cancel out both sides and make it a 1. So x minus 4 is equal to 1. Therefore x is equal to 5. Okay, so looking back at this graph, when y is equal to 3, this point is equal to 5. So basically, all the points that are greater than 5 and less than 4 is the solution to this question. So again, the question is asking when is y less than 3. It's less than 3 over there and less than 3 over there. Okay, so part 2, it's when x is less than 4 or x is greater than or equal to 5. Okay, make sure you write this equal to, because we want the case when x is less than or equal to 3. But I can't write equal to 4 because it's an asymptote. Okay, now part C. It says that x double dot is equal to minus e to the minus 2x. Okay, it is initially at the origin, so at time at t equals 0, x is equal to 0, so that's what it means, and it's traveling with a velocity of 1 meter per second, so x dot is equal to 1. Okay, so what we need to do is integrate this. So to get x dot, we need to integrate this side. Okay, I'm going to write x double dot all over e to the minus 2x is equal to minus 1. Okay, Now this e to the minus 2x can become e to the 2x. This is d squared x dt squared, which I'm going to take to the other side. And I'm going to integrate this between 0 to t and 0 to x. So, sorry, remember that at t equals 0, x equals 0. That's why I had this one. But I'm only going to integrate it once. Okay? So, okay, let's try this. Okay, maybe I'm taking the wrong approach here. All right, let me come back to this.